Today we're looking at function notation in lesson 5.3. And we're going to use and interpret function notation and evaluate a function for specific values of the domain. Remember, the first lesson of this section we learned what a function was. One input has exactly one output. The second lesson we learned domain and range. And now we're looking at function notation. Excuse me, I had to sneeze. So let's look at it. When referring to the functions in item 8 in lesson 5.2, it can be confusing to distinguish among them since each begins with y equals. Function notation can be used to help distinguish among different functions. For instance, the function y equals 9 minus 4x in item 8a can be written instead using the f of x notation, f of x. And we just replace the y with this notation instead. Okay? Does it mean f multiplied by x? It means the x is what you're going to replace your input variables with. So if this is f of 5, you would replace any x's with 5. It's just sort of a streamlined way to write functions. F a function, and then you have a composite of what you're replacing it with. Notice that the f of x equals y. It's the same thing. We just don't write the y now. We're going to write f of x. For domain values x, the associated range value is going to be f of x, which makes sense since before we had x is our domain and y is our domain. Our range. Well, now y is being replaced with f of x, so f of x will be our range. To distinguish among different functions, it's possible to write using different names. Use the name h to write the function from item 8b using function notation. So what this means is instead of writing f of x, we're going to write h of x. Okay? Think of f of x, think of the f as like a placeholder. You can write it as f of x, h of x, g of x. When we have multiple different functions, we want to be able to tell them apart. And so we don't want to all name them f of x equals, we don't want this. Let me just write it to show you. F of x equals 5x plus 2. We don't want to also have another one that's called f of x equals 6x to the second power or something like that. We don't want all of ours to be written as f of x. And so we're going to start replacing the f with h or g, so to help tell them apart, which was the whole point of writing f of x, to help tell them apart instead of just doing y equals this and y equals that. So let's do what the problem says. We're going to have f of x. Oh, actually it says use h of x. It specifically told us to do h of x from 8b. So we'll go back and we'll see what 8b said. Y equals 1 over x. All right. And so we'll just write instead of y, we'll write h of x equals 1 over x. So we're just trying to not confuse you too much, but instead of y, we're going to write f parentheses x in parentheses. And instead of sometimes using f, we'll use h or g. F is just sort of the name, and you can name it h, you can name it g. This problem told us to use h. Function notation is useful for evaluating functions for multiple input values. To evaluate this function, f of x is equal to 9 minus 4x for x equals 2. We can substitute 2 for the variable x and write f of 2 equals 9 minus 4x. So instead of this, we can shorten it to just this. So that saves us this part, 4x equals 2. We just say, okay, x is 2. We'll put that in for the 2 right here, x right there. And now we can replace our x with 2. And if we simplified it, 9 minus 4 times 2, 9 minus 8, 1. So let's look at number 2. Using the function notation to evaluate f of x equals 9 minus 4x for x equals 5, x equals negative 3, and x equals 0.5. So we'll write this as f of 5 equals 9 minus 4 times 5. We'll need to do f of negative 3, and that would mean it's 9 minus 4 times negative 3. And then we'll do f of 0.5, which equals 9 minus 4 times 0.5. All right, 4 times 5 is 20, 9 minus 20 is negative 11. 4 times negative 3 is negative 12, 9 minus negative 12 is 9 plus 12, which is 21. Half of 4 is 2, 9 minus 2 is 7. And there we go. All we're doing is replacing x with the number they tell us to, just like we've done multiple times before. And we're putting it in our function notation form so that we can show our different ones and what the answers would be. All of these are named f because they all follow the same basic equation, 9 minus 4x. So these are all functions of that expression. All right, number 3. Use the values for x and f of x from item 2 and display the display the values using each representation. And so the list of ordered pairs. I probably shouldn't have erased what I just did. All right, so if I put in 5, I got out negative 11. I put in negative 3. I got out 21. And if I put in 0.5, I got out 7. That's a list of ordered pairs from item 2 using the values of x and when we plugged in f into the function. The table of values, we're going to put this into this table. They've already got the input, the x coordinates in there for us. We just need to put the outputs. So negative 11, 21, 7. Okay. Mapping. Mapping is a little tricky. Let me use the drawing part. Five, negative 3, and negative 0. All right. This is much easier to do in your own book instead of doing it here, but we do it the best we can. What are the answers? Let's see. Negative 11, 21, and 7. All right, there we go. Mapped. Negative 5 goes to negative 11, negative 3 goes to 21, 0.5 goes to 7. And then we do it on a graph. We'll use the graphing calculator. Five goes with minus 21. Negative 3 goes with 21. And 0.5 goes with 7. Might need to zoom out a little bit so we can see our 3 points. There you go. Now, given this function f of x is equal to 9 minus 4x as shown above, what are the results? What is value of x results in f of x equals 1? All right, so this time we're not saying replace the x with 1. We're saying that this function, 9 minus 4x, equals 1. 1 equals 9 minus 4x. And so we need to solve it like we have done many times before. We will need to subtract 9 from both sides. One minus 9 will be negative 8. And 9 minus 9 is 0, so we're just left with negative 4x. Okay, we'll need to divide both sides by negative 4x, or negative 4, to give us what x equals. Negative 8 divided by negative 4 is 2. Negative 4x divided by negative 4 is 1x, so x. 2 equals x. That will give me 1. Let's see. 4 times 2 is 8. 9 minus 8 is 1. Yes, that makes sense. In number 5, we would do the same thing as we did in the beginning when we replaced the x with these numbers and worked it out. See, right here. Number 5, we're going to replace x with negative 5 and with 4/3. So we would find what f of negative 5 is when it equals 2 times negative 5. We replace x minus 7. We're going to see what f of 4/3 is when we replace the x with 4/3 minus 7. All right. 2 times negative 5 is negative 10, minus 7 is negative 17. 2 times 4/3 is 8/3, minus 7. 8/3 minus 7. Well, 7 is 21/3. So 8/3 minus 21/3 is negative 13/3. And we could write that as negative 4 1/3. We're just replacing the x with what they tell us using our function notation. B, g of x, same as f of x. C, h of x, same as f of x. We replace the x's with what they told us in negative 5 4/3. They made one little mistake. This is an equal sign right here. Okay, it's not g of x minus, it's equals. G of x equals 6x minus x squared. And so you'd replace x with minus 5 and work it out. You would replace x with 4/3 and work it out. H of x, same thing. Replace x with minus 5 and work it out. You replace x with 4/3 and work it out. Number 6, recall the money changing machine from item 3 in lesson 5.2, in which the customers can insert up to 5 $1 bills at a time and receive an equivalent amount of quarters. The function f of x equals 4x represents this situation. What does x represent and what does f of x represent? Well, x represents the number of dollar bills you put in. F of x represents the number of quarters you get out. A function whose domain is a set of positive consecutive integers forms a sequence. We've talked about sequences before. It's a list of numbers. The terms of the sequence are the range values of the function. For the sequence 4, 7, 10, 13, we have f of 1 equals 4, f of 2 equals 7. Domain is the x, range is the y, or what f of x, remember, is y equals. And so here it is. Consider this sequence, -4, -2, 0. What is f of 3? Now, if you'll notice, the first x that we replaced gave us 4. The second one gave us 7. The third one gave us 10. The fourth x gave us 13. Similarly, we're going to do that here. What is f of 3? It's the third one in that sequence. This is f of 1, f of 2, f of 3, 0. What is f of 7? 1, 2, 3, 4, 5, 6, 7, 8. So when we have a sequence, the x is the domain. That means this is the first one, the second one, the third one, the fourth one, the fifth one, the sixth one, the seventh one, and then keep going. And the range is the number in the domain, the value. Okay, try and look at this again to make sure you got that. We've been doing a couple of different things using function notation. And during this sequence, the function notation is telling you which one you're looking at in the sequence. Third one you're looking at, the seventh one you're looking at. Let's look at number 8 and see if we understand. Evaluate the functions for the domains values indicated. Okay, they want us to work this function out. P of x equals 3x plus 14. Remember, P of x is the same as f of x, is g of x, is h. It's just another way to name it. So we want to evaluate it for -5, 0, and 4. So I will replace this with -5. 3 times -5 is -15, plus 14 is -1. Replace it with 0. 3 times 0 is 0, plus 14 is 14. Replace it with 4. 3 times 4 is 12, plus 14 is 26. Same here. We need to replace them with these numbers and work it out. Again, I think they made a mistake here. So hold on just a second while I check. Yep, they made another mistake. This time, this should be a minus sign. T squared minus 5t. And so if you replace the t with -2, that'd be 4. -2 times -2 is 4. Minus 5 times -2 is -10. Minus 10. 4 minus -10 is 14. Replace it with 0. 0 squared is 0. Minus 5 times 0 is 0. 0. Replace it with 5. 5 squared is 25. Minus 5 times 5, which is 25. 25 minus 25 is 0. 7 squared is 49. Minus 5 times 7, which is 35. 49 minus 35 is 14. Okay, consider the sequence. What is f of 2? Here. What's f of 5? 1, 2, 3, 4, 5 here. Remember, when we're dealing with sequence, the f of is telling you which number you're looking in the sequence. Okay. 10, 11, 12, and 13. We should really want to try on our own just to make sure we do know what we're talking about. Write the function in function notation. That means instead of y, you write f of x. And then it's here. F of x equals this part. Replace y with f of x. That's function notation. That's what we're mainly concerned about today. Evaluate that function for -2. And so you will replace the x. You're going to say, what is f when -2? When x is -2. That's expressing it in function notation. Then you'll have to actually work it out. -2 squared minus 3 times -2 minus 4. Make use of the structure. For what value of x does f of x equal -4? And so you would need to say -4. So I haven't finished these two. I'm just letting you know. Do 10 and 11 yourself. Number 12, though, -4 is equal to x squared minus 3x minus 4. We need to know what value of x does this come out to be -4. Well, 0. We'll put a comma there. This, if 0 squared is 0 minus 3 times 0, which is 0, you're left with -4. -4 equals -4. Okay? There is one more number that can give you -4. If x squared minus 3x is 0, what number squared minus 3 times that number would give me 0? Well, it turns out it's 3. 3 squared is 9, minus 3 times 3 is 9. 9 minus 9 is 0. You're left with -4. So this one actually I'm doing for you because it has two answers that you might not be able to think about if you don't think critically. You want to know that this section has to equal 0 for -4 to equal -4. Well, that happens when this is 0, so 0 squared minus 3 times 0, which is 0. And it happens when this is 3. 3 times 3 is 9, minus 3 times 3 is 9. 9 minus 9 is 0. So it happens twice. And then this sequence just, what is the fourth one? That should be simple enough. You can do 10, 11, 12, and 13. I mean, I did 12 for you, but you can do 10, 11, and 13. And hopefully we all saw function notation today, which is, oops, let me go back. Just using f of x instead of y and working it out using this new notation. Same as we've been doing. It's just instead of y, we're going to be writing it in function notation.